Imagine standing on a sun-drenched beach. Then suddenly, the solid ground beneath your feet jerks to a dead halt while you, the sand, and the entire ocean are fired eastward at over 1,000 miles per hour. Could you survive the instant our planet quits its 4.5 billion-year-old dance, or would the nightmare just be getting started? The terrifying winds and towering waves are just the beginning, because the real killer is something completely invisible, a silent force that won't strike until the dust finally settles. From the edge of space, the thin blue atmosphere begins to shear as air keeps racing while the ground has stopped, cloud bands tearing like fabric around the limb of the Earth. Dropping to low Earth orbit, we watch coastlines convulse. Torn contrails smear the sky while seas pile eastward, momentum carving scars into every shore. And as we pull back, violent weather bands coil into planet-sized spirals, a world hammered by inertia as oceans and sky rearrange in seconds. The moment Earth stops, physics turns into a global executioner. Because of inertia, everything not bolted to the bedrock, including you, your house, and the billions of tons of water in the sea, continues hurtling forward at the same speed Earth was just spinning, which at the equator is a blistering 1,040 miles per hour. You wouldn't be launched into the cold void of space because gravity would still be clawing at you, but you would be whipped across the landscape like a rag doll until friction finally ground you into the dirt. But even if you survived being thrown across a continent, you're about to face something far more violent. High above, the air keeps going. The atmosphere lags behind the crust, tearing sideways. Cloud bands shear along continental edges, jet streams buckle, and pressure walls ignite storm lines that rip long, smoking scars across the surface. At sea level, inertia turns ports into threshers. Container cranes and stacked boxes wrench east in a single grinding lurch as harbor water vaults over breakwaters, hurling steel, fuel, and ships through concrete. And the worst of it hammers the equator. That's where spin speed was highest, where cities, jungles, and oceans keep racing forward the fastest. Along this glowing belt, skyscrapers peel, highways unspool, rail lines scythe through neighborhoods, and entire shorelines leap inland. Farther from the equator, the speeds drop, but devastation still fans across continents. Dust plumes, fire lines, and blackouts chasing the dawn. When the tumbling finally slows, the world is a new map of wreckage. Power grids shredded, coasts redrawn, and billions of tons of debris suspended in a storming sky. And yet we've only seen the opening act. Momentum has more to spend. As the ground goes still, the atmosphere does not. A global windstorm erupts with wind speeds 5 times higher than the most powerful hurricane ever recorded, an Earth-sized engine of chaos. These 1,000-mile-per-hour gales would scour the planet's surface, shredding skyscrapers and uprooting ancient forests as if they were made of toothpicks. At the same time, the oceans, now vast, unleashed masses of momentum, would surge over coastlines and mega-tsunamis hundreds of feet high, turning the world into a debris-choked water planet. And it's about to get worse as the very ground beneath you begins to tear itself apart. From orbit, Earth would wear belts of hypercanes, bands of storm stacked upon storm, while continent-spanning dust plumes smear the skies and lightning webs stitch the darkness. Ash, salt, and shredded cities spiral into the troposphere as the atmosphere screams around a motionless world. And beneath that raging shroud, the planet's crust strains toward a breaking point. The violence won't stop at the surface. The violence wouldn't stop at the surface. The sheer stress of the entire crust decelerating in an instant would rip along every fault line at once, triggering earthquakes and volcanic eruptions on a scale humanity has never witnessed. Molten rock would tear through the ground, choking the sky with a bruise-colored shroud of smoke and ash. By the time the winds calm and the waves recede a few hours later, the world has reached a new, terrifying equilibrium. But that's not even the strangest part. Earth isn't a perfect sphere. Its spin creates a centrifugal force that makes it bulge at the center, holding the sea level at the equator about 13 miles higher than at the poles. Without that spin, that mountain of water has no reason to stay there. It would begin a slow, inevitable migration toward the north and south poles, draining the equatorial regions. As the water retreats, a giant supercontinent would emerge like a rising titan, circling the middle of the globe and separating two vast new oceans. Today's mid-latitude coastlines would vanish beneath the rising water, while a barren, salty wasteland of former seafloor, once miles underwater, would become the only dry land left for any survivors. But even on this new supercontinent, you would quickly realize that time itself has broken. While Earth has stopped spinning on its axis, it is still locked in its year-long orbit around the Sun. This means the 24-hour cycle of day and night is gone, replaced by a day that lasts an entire year. For 6 months, the Sun would hang motionless in a sky the color of fire, baking the landscape in relentless, unyielding heat. Temperatures would soar past 200 degrees Fahrenheit, hot enough to boil away any remaining lakes and turn the daytime side of Earth into a scorched, lifeless desert. And if you think the heat is bad, the coming darkness is even more brutal. On the opposite side of the planet, you would enter a 6-month-long night where the stars never move and the temperature plummets into a deep, lethal freeze. The constellations would remain fixed in the sky, an eerie, unmoving ceiling over a world of ice. To survive, any remaining humans would have to become eternal nomads, forever chasing the Twilight Zone, the thin, moving sliver of moderate temperature where the sun is either just rising or just setting. But as you huddle in the dim light of a perpetual sunset, the hidden killer we teased at the beginning is finally coming for you. The deadliest consequence of a stationary Earth isn't the wind, the waves, or the heat. It's the collapse of our invisible shield. Deep beneath your feet, the rotation of Earth's molten iron and nickel core acts like a massive dynamo, generating the magnetic field that protects us from space. If the planet stops spinning, that dynamo shuts down. Our magnetic shield would vanish, leaving the atmosphere vulnerable to being stripped away by the solar wind and exposing every living cell to a lethal bombardment of solar radiation. Without that shield, even the hardiest microbes would see their DNA mutate and shred, and over time, that relentless radiation would sterilize the surface completely. The good news is that a sudden stop is virtually impossible in our modern solar system. While our spin is actually slowing down by about 1.7 milliseconds every century due to the moon's gravitational tug, it would take billions of years to come to a full halt. Long before the Earth ever stops turning on its own, our sun will likely expand into a red giant and consume the planet entirely. We are living on a spinning top that has been humming for billions of years, and that rotation is the heartbeat of everything we know. It's easy to take the sunrise for granted, but every morning is a reminder that our planet is still performing its great cosmic dance. If the music ever stopped, the silence would be the last thing we'd ever hear. But what if Earth didn't just stop? What if it started spinning in the opposite direction? To explore that backward reality and more mind-bending what-ifs of the cosmos, hit that subscribe button and join us here at Curious Lens.